Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to go over an exercise to find MacLaurin polynomials for the given functions. And what is a MacLaurin polynomial? It's a polynomial expansion, infinite series expansion of functions. And in the first exercise, we're going to keep only 5 terms. And in the second exercise, we're going to keep only 4 terms. Let me just quickly explain what a MacLaurin polynomial is before I start the video, even though I'm going to explain that in the video again. Well, to start with, the function that you're dealing with must have n derivatives at the point c, which will be called the center of the expansion, the polynomial expansion. Okay, so if c is non-zero, and if you write p sub n of x in terms of f and its derivatives evaluated at c, that is called an nth order Taylor polynomial of f at c. Okay, if c is specifically equal to 0, so you have the expansion around the point x equals 0 or c equals 0, that is called the MacLaurin polynomial for f, and it's the nth order because we keep polynomials, we keep terms up to the order n. So as you see that the last term over there here is x to the n, and the bottom also x minus c to the n. So that's where the nth order or nth comes from. Okay, so essentially what we're going to do is just we're going to find enough derivatives of the given function depending on what n is, and we're going to make function evaluations depending on if we expand it into Taylor or MacLaurin polynomials. But for our exercise, it's MacLaurin polynomials, so c is going to be 0. So we're going to check all of those derivatives and the function itself at 0 and bring them all, and that's going to be the Taylor expansion. All right, so we have 2 exercises to go. I'm going to split this video into 2 parts, and you will see 1 video for each case. All right, let's get started. All right, let's start. So let me just remind you what a MacLaurin polynomial is, but in the meantime, I'll show you what the Taylor polynomial is. So let's say like you have a function f, and that has n derivatives, so it's differentiable n times at c. So the polynomial, which is constructed by the help of the derivatives of f, including itself, so f of c, f prime of c, which is a number times x minus c, f double prime of c over 2 factorial x minus c squared, and finally all the way to the nth derivative of f at c divided by n factorial. This notation means like you're talking about the nth derivative, okay? All right, so as you see that you have x minus c, a hypothetical 1, and x minus c to the n. So this is a polynomial. We call it like p sub n of x. This is called the nth Taylor polynomial of f at c, okay? And c could be any point when you talk about a Taylor polynomial. But if c in particular is chosen to be 0, then that expression, that polynomial expression becomes, in fact, it's simplified, and it becomes the nth MacLaurin polynomial for f. Okay, so the difference between Taylor and MacLaurin polynomials is that one is expanded into a polynomial, so f is expanded into a polynomial at x equals c, and in the other case for the MacLaurin, it's at x equals c, which is equal to 0. Okay. All right. So introducing the MacLaurin polynomial, nth order MacLaurin polynomial for functions. So we are given in part A f of x equals cosine pi x and n equals 5. So that means I'm going to keep the derivatives up to the order 5. So let's start. So why don't we have f of x? Let me just write f of x equals cosine pi x. I need the derivatives of f up to the order 5. So I need f prime, I need f double prime, I need f triple prime. After the triple prime, we use the parentheses notation to denote the derivatives. Okay, the 4th derivative and the 5th derivative. Okay, all right, 5th derivative. Just rewrite that. Okay. All right. So you can use this as a good practice for applying the derivative rules that we learned earlier. So what is the derivative of cosine pi x? So it's the application of the chain rule. The derivative of the inner part is pi, and the derivative of the outer part, which is cosine, is minus sine the inner part the same. Okay. And now I'm going to take the derivative of f prime to find f double prime. All right. So the derivative of the inner side is pi. You have already minus pi out there. So minus pi squared. And the derivative of sine is cosine. There we go. Cosine pi x. Okay. And similarly, you're going to have pi cubed sine pi x. You can pause the video and then just go through those derivatives on your own pace. Okay. Pi to the fourth cosine pi x. And eventually minus pi to the fifth sine of pi x. Okay. So once you collect all of the derivatives, you need all of these functions evaluated at c equals 0, x equals c, so x equals c equals 0. Okay. So in other words, c equals 0. All right. So why don't we have f of 0? Let me just list them all here. How about that? Let me just separate this part from here. Okay. All right. F of 0 is cosine. You can have your TI-84 with you, and then you can do the calculations on your TI-84. Cosine pi times 0, cosine 0, which is 1. Okay. F prime at 0. Well, sine 0 is 0, so all sine related terms are going to be 0. Okay. So okay. F double prime at 0 is pi, negative pi squared cosine 0, which is negative pi squared. And finally, the fourth derivative evaluated at 0 is pi to the fourth. Okay. So once you have all the derivatives evaluated at 0 up to the order 5, we go ahead and then write the MacLaurin polynomial, which is P5 of x. So P5 of x. There we go. P5 of x. So which is f of 0 plus f prime of 0x plus f double prime 0 over 2 factorial f triple prime 0 over 3 factorial. This is x squared as well. X cubed plus f fourth derivative evaluated at 0 over 4 factorial, right? And then finally f evaluated at fifth derivative, like the fifth derivative of f evaluated at 0 divided by 5 factorial, x to the fourth, x to the fifth. Okay. All right, from this moment on, I'm just going to plug in those values. So here we go. F of 0 equals 1. 1 plus, well, f prime of 0 equals 0. I'm going to skip that term because it's 0. But if you want, I can just write it for you to see. 0 times x plus f double prime at 0 is negative pi squared over 2 x squared plus 0 times x cubed. Okay. All right, so 0 times x cubed, pi over pi to the fourth divided by, this is 2 factorial, 4 factorial. You can also put 1 factorial here, but again, we don't need those. X cubed over 3 factorial, x over 1 factorial, right? This is x to the fourth over 4 factorial. Let's be precise, okay? 4 factorial, x to the fourth. And then finally, the fifth derivative is 0. 0 over 5 factorial, x to the fifth. Okay? So, so let me just erase this part all the way. so that we can actually list those only here. Okay, so you have 1 minus pi squared over 2x squared plus pi to the 4th divided by 24x to the 4th. Okay, so the MacLaurin expansion of cosine pi x, keeping the terms up to n equals 5, order 5, gets you to a polynomial of order 4. Okay, so